Hi guys, good morning. It's another lovely Tuesday. I hope you guys have been having a great day. Okay, so today we're going to be talking about physics. We're going to be discussing physics, and we're going to be looking at a very interesting topic, another topic today. Now, but before that, I want you to look at something. Okay, so let's talk about some fun facts. Are you ready? Okay, let's go. Um, Now, I want you to look at this man. Who is this man? Who is this man? Try to guess, try to guess. Who is this man? Some people are saying probably Isaac Newton. No. Let me see. Which other person would you guess? It's not Albert Einstein. We looked at Albert Einstein's picture in the last one. Okay, which other person could you possibly have guessed? I really don't know. But whichever person you have guessed, let me tell you who that person actually is, who this man is. His name is Galileo Galilei. Nice name. Actually, I like the name. Galileo Galilei. Okay, so what's so special about him, or what do I want you to know about him? He has done so many things actually. In fact, he went through a lot of, you know, should I say persecution for the theories he postulated actually. So he kind of like suffered to get us the knowledge that we have today. But let's just say, you know, let's just look at something. Let's just look at the positive parts and let's just see what he did. Okay. So now, the first thing that I can say, okay, we are all familiar with or we've heard of, are telescopes. You know telescopes. You know what they're used for. We use them to see far objects that are very far away. So he has contributed a lot. These telescopes actually, help with, watching the stars, seeing planets, planetary bodies, and the likes. So Galileo was not just a physicist; he was an astronomer also. Okay, he was an astronomer also. So let's talk about, let's go further and deal with, telescopes, and let's see how everything came about. Okay, now first of all, you need to note that, okay, Galileo did not invent the telescopes. He did not invent telescopes, he did not. But, okay, we'll get to that. Now, it was invented by Dutch eyeglass makers, okay? It was invented by Dutch eyeglass makers. But what did Galileo actually do with these telescopes? He made significant improvements to it. Okay, I think when he first started, his telescopes had like a magnification of 3 times. Then that same year, I think by as a fall of that year, he had moved to like 20 times. His magnification of his lenses were now like 20 times. Now, what does that mean? He could see farther. His own lenses were able to magnify farther than, what even the Dutch eyeglass makers were able to do. So he got us greater magnifications. So we were able to see farther, we were able to see clearer and all that because of this man. Okay, so when you hear NASA is going to send an aircraft, a spacecraft into, space. They're going to look at this planet. They're going to Mars. They're going to Jupiter. Galileo Galilei actually contributed to that. He actually contributed to that. Okay, and he was one of the people that made significant contributions to that. Okay, let's look at something else. Now, apart from telescopes, there are some other things he did. Now, let me show you one that was really very important. Now, I don't know if you've heard of Kepler. Kepler has some laws also in physics. Yeah, I don't know if you've heard of him. Now, he supported Kepler to prove that the Earth revolved around the sun. Now, this theory also had been developed before by Nicholas, okay, like half a century earlier. But then Kepler and Galileo came together and they said, oh, let's prove this. Let's actually prove. Okay, let me tell you that there was a time where it was believed that the sun was the one moving around the Earth, you know. But it was these two people that actually told us and proved to us. They did not necessarily develop the theory, but they proved it and they said, oh, no, 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 no. It's the other way around. The Earth revolves around the sun. So you can imagine. Now, they believed that the sun and not the Earth was the gravitational center of the universe, upended almost 2,000 years of scientific thinking. Imagine, all along, everybody had actually believed the same way we once believed that the Earth was flat. No, all along they had actually believed that, oh, okay, the sun or the earth is the, because we're on earth anyway, so the earth is the center of, the gravitational center of the universe. But they said no, no, it's the sun, because the earth, revolves around the sun and not the other way around. And this was one of the things that actually put him in a lot of trouble. Okay. Now, after some time anyway, his work was now, accepted and recognized, and people realized that, oh yeah, this man was actually right. He was actually right when he said all these things. So in 1995, that's just how many years back? Okay, it's actually it's actually a long time, but not too long ago. An unmanned NASA spacecraft, actually named after him now, landed on Jupiter. Landed on Jupiter to begin, a study of Jupiter, the moons around Jupiter, and which Galileo actually helped to identify in 1610. That was like, you know, almost, I don't know, 400 years or so ago. So imagine, in fact, it's even more than 400 years ago. It's so just imagine, 1995. Okay, NASA finally, took a spacecraft into Jupiter and landed on Jupiter, and that spacecraft is actually named after Galileo Galilei. So it's just fun to tell you that this man actually has contributed a lot, especially to astronomy and to physics. Understanding the gravitational universe, gravitational center of the universe is a very important thing. So I think, if you agree with me, I think he was a very important person. So that's that for Galileo Galilei. So that's that for that. Okay, so let's move on to what we want to do today, which is, first of all, what do you need to know? And I'll tell you what we want to do today. But from what, if I tell you what you need to know, then you should be able to figure out what we're doing. So let me just tell you what you need to know. Number one, and the major thing is, you need to know how to use the equations of motion. Of course, you need to know them, be able to prove them, and most importantly, be able to apply them. Okay, so that's what we're going to do. So from there, you can already guess that our topic is equations of motion. I love this topic. Actually, I love most of the topics of physics. There are just some that, let me not say I don't love them, but I love some more than others. And this is one of the topics that I actually love. I hope you can come to like it too. So equations of motion. Okay. Now, before we can even talk about equations of motion, we actually talk about, there are actually two different aspects. We have dynamics and kinematics. Okay, we'll get into that. But let me just tell you something about motion first. Okay, let me tell you something about motion first before we can talk about equations of motion. Now, what is motion? What is motion? Now, the motion of an object can be defined as, the visible movement of that object between two different points, which can be caused by an applied force. Okay, so let me just give you an example. Now, you're sitting maybe at the balcony of your house, and then you're just looking outside. You're looking down, and you can see a lizard, and the lizard is actually at a particular spot. And then all of a sudden, the lizard just runs so quickly and moves somewhere else. That's an example of motion. That's just one quick example of motion. Okay, so the lizard actually made a visible movement between two points. Okay, now it can be caused by a force, it can be caused by an applied force. Motion can actually be caused by a force. Now, another way to put it is to say that it is the phenomenon in which an object changes its position over time. Okay? It changes its position from one point to another over time. That's another way to, define motion. That's another way to define motion. Now, I was talking about dynamics and kinematics the other time. Now, dynamics, when you talk about dynamics, it has to do with, okay, not just studying motion, but also talking about the force behind this, the force behind this motion. While kinematics, okay, deals with, okay, the objects in motion, the motion itself. Okay, so that's that. Now, but let's take examples of motion. You can see that boy is running. He's running. It's running, and he's in motion. Exactly. That's what we say. He's in motion. We say, okay, this boy is in motion. Or you see a car moving. You say this car is in motion. Let's get another one. So you can see this girl on the power bike. She's also in motion. She's in motion. She's moving from one point to another. So I think with that you can have an idea of what motion actually means. You practice it every day. You stand up from your bed, you go and get maybe breakfast, then you move, you go out of your house, you go to school, or even if you're not going to school that day, you walk around the house. That's motion. That's motion, right? Okay. So now, but there are different types of motion. There are different types of motion. Now, let's look at the types of motion. Okay, so we have translational motion, we have oscillatory motion, we have random motion, we have circular motion, and we have rotational motion. Okay, so we have different types of motion. I'm going to just look at each of them and just give you a brief, rundown about each of them. So look at translational motion. What's translational? Translate. Translational motion doesn't mean necessarily the one you're used to, where you move from one language to the other. Anyway, so translational motion simply means the motion of a body in a straight line as a result of force that is applied. So you're moving the body is moving in a straight line, okay, as a result of an applied force. Let's look at this. So you can see this lady, she's actually pushing a stroller. Now, if she moves the stroller in a straight line, that's translational motion. You see this in the supermarket. See this in the supermarket. So when you see a person pushing a stroller, or a woman with a baby in a stroller, and then she's pushing that baby in a straight line, that is translational motion. Okay. Now let's look at oscillatory motion. What's oscillatory? To oscillate. To oscillate means to move about a fixed point. So the motion of a body about a fixed point is oscillatory motion. Look at this. This is a pendulum. Now the pendulum is swinging from side to side, from side to side, from side to side. That is oscillatory motion. I don't know if you've seen a pendulum clock, a clock that uses, pendulums. Yeah, you might have. So the next one, rotational. Let's talk about rotational motion. Now, rotational motion is the motion of a body that moves in a circle or ellipse form and rotates about an axis. It rotates about a particular axis. Okay, so look at this. For example, everyone knows what a fan is. So now, sometimes when you see a fan blade, you see the blades. You can, if it's not connected to electricity, you can even roll them around with your hand. That's if it's not connected to electricity. So you see that, these blades actually are moving about that center. They're moving about that center. They're rotating about that axis there. Okay, so that is rotational motion. Then random motion. Okay, this one is funny. I'll tell you why it's funny. Now, this is a type of motion with no specified direction. There's no specified direction for random motion. You can see this motion of these particles, they're just moving in any random direction. Now, there's an example they used to tell me when I was in school there. An example of random motion is the motion of a drunk man. Although some people can be drunk and still walk in a straight line, but I don't think so. If a person is a person that is a drunk that just drinks, aimlessly, will not be able to walk in a straight line. So that is random. That is an example of random motion. Okay, so that's another fun example of random motion. Okay, yeah. So now circular motion. When you say a body is moving in a circular motion, what does that mean? It means the motion of a body in a circle. It's moving in a circle at a constant speed. It's moving in a circle. Now let's just look at a fun example of that. Have you ever been to an amusement park? Then you know what this is. I don't like this thing. I don't think I can't remember ever getting on one, and I don't ever hope to be on one. It's too scary. But some of you are, you're brave people, so you can do that, but it's too scary for me. So when you go on the merry-go-round, it takes you round and round and round in a circular motion, okay? So that's a very good example of circular motion. All right, now let's start with the equations. Now, we talked a lot about the motion part. Now, these equations I'm going to show you are for uniform acceleration. There are different types of motion, okay? You can have projectile motion, where you project a body at a particular angle. Those, the equations you use there are different. You can have motion under gravity. Maybe you're throwing a body up or throwing a body down. Those equations are also different. We'll would have the opportunity to also look at those equations. Okay, but today we're going to be considering a body that is moving with uniform acceleration now. Okay, so let's look at the equations together. Now this is going to be a long journey. We're going to prove them. So just sit back and try to follow me step by step. Okay, so first of all, you remember this formula? We talked about this formula when we were talking about speed, velocity, and acceleration. We said average velocity is, v plus u, that's the final velocity over plus initial velocity over 2. So try to remember this, you collect this formula. Now, but we know now that distance is average velocity times time. Remember that distance is average velocity times time. So we can write S as v plus u over 2 times t. Let's call that equation B. Okay, I'll tell you why we need equation B later. Now, if you also remember clearly, you know that acceleration, we talked about acceleration A as v minus u over t. That's final velocity minus initial velocity over time. We talked about that also. Now, if you look at this clearly, we can rearrange this formula for acceleration by cross multiplying, right? So we can have v minus u equals to a times t, which is at. Okay, we cross multiply there, so we have v minus u equals to at. Okay, now this can now be written as v equals to u plus at. Okay, this can now be written as v equals to u. As you take u to the other side, it becomes positive, so u plus at. Okay, so that is the first equation of motion. That's the first equation of motion. Now, you would see why we need equation B as time goes on. So just take note that from the formula for acceleration, we can actually rearrange and get a formula for velocity now, final velocity, as v equals to u plus at. And we usually call that equation 1. Okay? Now let's talk about equation 2. Now this equation talks about the distance covered by an object. So we want to derive an equation for the distance covered by an object moving with uniform acceleration now. Okay, so remember this equation B that I told you about. Okay, let's bring it back. So distance S is v plus u over 2 times t. Now, remember this other equation we just derived, equation 1? Okay, so v equals to u plus at. Okay, now what do we do here? Okay, we're going to do this. We're going to substitute equation 1 into equation B now. Don't worry, it's fun. We're going to substitute equation 1. We're going to put equation 1 into B. Okay, so this is what we're doing. 1 to B, 1 into B, 1 into B, 1 into B. Now, it means that wherever we see B, you can see my B, I put a mark on it. So wherever we see B, we're going to put u plus at instead. We don't want to put B, we don't want to have B in that equation. So we're going to substitute B as u plus at. So let's look at how it's going to look like. So we're going to have S is 1 over 2 into, so we're going to remove B now and put u plus at plus u times t now. Okay? So that's what we have. Then we try to simplify the inner brackets. So u plus u should give us, 2u. So we have 1 over 2 into 2u plus 80 into t. I hope you're following. Just take it step by step and try to follow. Now, what do we do next? You can see that we have 1 over 2 outside the brackets. So we're going to try to use 1 over 2 to open the brackets. Okay? So 1 over 2 times 2u would give us u, and 1 over 2 times 80 will give us 1 over 2 80. Now remember that we have a t outside the bracket. So we would have ut plus 1 over 2 at squared now. Okay? So that is now what we call our equation 2, which is an equation that shows the distance, covered by an object moving with uniform acceleration. So S equals to ut plus half at squared. That is equation 2. Okay? Follow me to the third one. Now, we can also derive a formula for final velocity again, but using different parameters. We don't want v equals to u plus 80. We want another set of parameters for the velocity, final velocity of the body in moving with uniform acceleration. So let's get our equation B again, yet again. So S equals to V plus U over 2 times T. Then let us now get this equation for acceleration. Remember that we said acceleration is V minus U over T, right? But we want to rearrange and get T now. We want to get T now. So if we rearrange and we will try to get T from that formula, we would have V minus U over A now. V minus U over A now. What do we now do next? Okay, so we are now going to substitute equation C into equation B. Okay, I'm going to put equation C into equation B. So how does that work? C into B now. C into B now. It means that wherever I find T now, you can see I put a mark on T. Wherever I find T now, I don't want to put T there again. I'm going to replace T now with V minus U over A. Okay, so our equation should look like this now. S is equal to V plus U over 2 into V minus U over A now. Okay, now we're going to open the bracket by multiplying. Let's start with the numerator. If we do V times V, we should get V squared. If we do V times minus U, we should get minus UV. U times V will get plus UV. So minus UV and plus UV will cancel out. And then U times minus U will give us minus U squared. So we're going to be left with V squared minus U squared as the new denominator now. Sorry, as a new numerator now. That's the one on top, numerator. Now for the denominator, it's quite simple. Just do 2 times A and we get 2A. So our new equation is going to look like this. S equals to V squared minus U squared over 2A. Take note that we were able to get V squared minus U squared by multiplying, by expanding the numerator. So we used V to multiply V minus U, and then we used U to multiply V minus U, and then we simplified. Okay? So but we're not going to stop here. We're going to, now, for an equation to be regarded as an equation of motion, it must be expressed in the simplest form possible. So we're going to try to simplify this by cross multiplying. So we should have 2as equals v squared minus u squared. Like I said, v squared minus u squared equals 2as. And then by the time we rearrange that, we want v squared to be the subject of the formula. Okay, so v squared will be equal to u squared plus 2as. Okay, v squared will be equal to u squared plus 2as if we rearrange that expression there. So this is what we call our third equation. So this is equation 3 for our motion of the body moving with uniform acceleration. Take note. Now, let's now do a combination of all the equations. So the first one, v equals to u plus 80. Now it's time for you to try to learn them. Apart from knowing how to prove them, which is important, you need to also put them in your memory so that you can recall them when you need them. Okay, so v equals to u plus 80 is number 1. S equals to ut plus half 80 squared is equation 2. And the third one is v squared equals to u squared plus 2as. Now you would see that there are some arguments that even equation B is part of the equations of, it should be, some people say there are not 3 equations of motion. In fact, there's a postulated, should I say postulated theory that there are 5 equations of motion. You can read up on that, but we're just going to say for now that we are going to be using this major 3. We added the 4th one because sometimes you actually need it to solve, some questions. So it's important that you know everything. It's important that you know everything. Okay, so let's look at some examples. I know we've been talking about proving. Some of us don't like proving, I know. But sometimes you need to know how, these formulas were actually derived or actually arrived at. You shouldn't just, just take it in and just say, okay, this is it. I'm just going to learn it and I'm just going to know it. Sometimes you need to know step by step, okay, how was this formula derived? It's important. And if you take it step by step, it might be long. Sometimes one thing about proofs is that they can be long, but if you take your time step by step, they are not difficult. I know some of us don't like things that are long, but you just need to discipline yourself to just try to wait it out and take it to the end, take the whole process. Okay, let's take some examples. So look at this. Number one, a car traveling at 54 kilometers per hour slows down, okay, uniformly to a velocity of 18 kilometers per hour when the brakes were gradually applied. Okay, number A, you have to find how long it takes to cover a distance of 50 meters, and B, you have to find the deceleration. So this is our car. So that car it was fast at the beginning, it became slower. So automatically your initial velocity is higher than the final velocity. Then, knowing that, you should know that it didn't accelerate, it decelerated or it retarded. Okay, so let's try to solve. Let's start with the first one. So we have to find the distance, sorry, the time it takes. When you hear how long, time. When you hear how far, distance. Okay, how fast, speed. Take note of those keywords. Okay, keywords. So how long, time. So let's write out the parameters that we have and the one we are looking for. So we have initial velocity is 54 kilometers per hour, which we cannot read in kilometers per hour, which has to be converted to meters per second. Okay, so we do that by multiplying by 1000 and dividing by 3600, and then we get 15 meters per second. Then our final velocity is 18 kilometers per hour, which also will be multiplied by 1000 and divided by 3600 to change it to meters per second. So that will give us 5 meters per second. So that's our, final velocity. Then our distance covered is 50 meters, and then what we're looking for is time. So we say time is unknown. Okay, now let's bring back our equations. Okay, so this is a list of our 4 equations. Now we need to know that this is where the word comes in. You need to know the equations. Now then you need to know which particular one you're going to use. Now that depends on our parameters in red. You can see our parameters in red. U, V, S, and T. So what you need to do is go to the formula and look for a formula that has these 4, parameters. So let's start with the first one, B, U, A, T. We don't have A, and we're not looking for it either. So 1 is out. 2, S is equal to UT plus half AT squared. We don't have A, so that is also out, right? 3, okay, A is in 3, so we don't have A, so A, that is also out. So let's go to B. We have S, B, U, and we're looking for T. So voila, we're going to use equation B. That is our equation. So the word also is, you need to know which one you're going to use. After knowing, okay, this is the way to derive these equations, and then these are the equations, I know them now in my head, and then I now need to know which particular one I'm supposed to use. So S is equal to V plus U over 2 times T is our winner. So we can say bye to the equations now. Say goodbye, yeah. So now let's use this formula. So S is 50, let's substitute. S is 50, V is 5, U is 15, and T is what we're looking for. So 50 equals 5 plus 15 over 2 times T. So 5 plus 15 is 20, divided by 2, that's 10. So 50 equals to 10T, and in essence, our T is 5 seconds. That's all. That's all. Now, 5 seconds. Seconds. I'm saying that over and over because it's very important. If you don't put your unit, you're going to lose some marks, because in physics, you need to have a unit of measurement. What the unit of measurement shows you what quantity you're actually looking at. So you need to put your seconds. Let's go to the second part. We're asked to find the deceleration here. So let's write out what we have. We don't need to start, deriving again or converting again. We already have U as 15 meters per second, V as 5 meters per second, S is 50 meters, T as 5 seconds, and we're looking for A. Now we're looking for the negative acceleration, A, negative A. So let's now come back and bring out those formulas again. Okay, so which one are we going to use? I want you to quickly think about it. Which one can we use? Okay, let me just tell you. Now, there's a variety of formulas we can use here. V equals to U plus AT. We have V, U, A, and T. We're looking for A, so we can use equation 1. For equation 2, we have S, we have U, we have T, and we have, we're looking for A, so we can also use equation 2. Let's look at equation 3. B, we have U, we're looking for A, and we have S. So you can also use equation 3, but you cannot use equation B because there's no acceleration there. Now, but when you know that you can use any of the equations, you have more than one option that you can use, please try to use the simpler one. So we're going to just take equation 1 and use equation 1. It's the simpler one here. Okay, so let's just put that B equals to U plus 80, and we say bye to the other formulas. So B equals to U plus 80, and then A now will be V minus U over T. I think we know that. So, our A now is 5 minus 15 over 5. Okay, that becomes, minus 10 over 5, okay, which now gives us minus 2 meters per second squared. Now, well, remember, I think I said this when we're talking about speed, velocity, and acceleration. They asked you to find deceleration, which is the negative acceleration already. So you don't need to still include the minus. Acceleration is minus 2 meters per second squared. But now the deceleration is already negative, so deceleration is 2 meters per second squared. Because we already know that the name itself implies negative acceleration. So to avoid tautology, you can just say the deceleration is 2 meters per second squared. Okay? So let's look at one more example. A body starting from rest travels at an acceleration of 4 meters per second squared. Determine its final velocity after covering a distance of 32 meters. So let's write out our parameters as usual. Parameters we have. Now you can see rest, it starts from rest. What does that mean? I said it previously in our last class. It means the velocity, initial velocity is 0 meters per second. So U is 0 meters per second. Then we have acceleration of 4 meters per second squared. We have distance of 32 meters, and we are looking for the final velocity, So let's come back to our formulas. Which one can we use? Take a moment to look at it and see if you can figure out which one can we use. Okay, so let's look at it together. The first one is B equals U plus 80. We do not have T, and neither are we looking for T, so we can use it. S also equals to ut plus half 80 squared cannot be used because T is also present there. But if you look at the third one, V squared equals U squared plus 2AS. We have V, we are looking for V, we have U, we have A, and we have S. So we can use equation 3. Okay, so our answer or our equation that is the lucky one is equation 3. So V squared equals U squared plus 2AS. Then we can get rid of that. So V squared equals U squared plus 2AS. So we can now substitute. V squared equals 0 squared plus 2 times 4 times 32. Okay? So V squared equals to 256. And then if you find the square root of 256, you should have V as 16 meters per second. So that is your final velocity. Okay? All right. So let's summarize. So basically, we've gone through different stages. We talked about motion. Then we said the types of motion: translational, rotational, circular, oscillatory, random, and the likes. Then we moved to the equations, how to derive these equations. Very important. You can do it over some time. You can familiarize yourself with it over some time. You might not be able to just remember all the proofs at once, but if you're doing it over time, you get it. Okay, so then we went to the proof, the proofs of the theorems, and then of the equations, and then we now saw how to apply these equations. Now, to apply these equations, the first thing you need to do is to analyze your question. So you need to know, okay, what are the parameters I have, and what do I need to find? If you can do that, then you need to now have the equations here, and then look at them and say, okay, which equation helps me with the current set of parameters that I have on ground. And then when you're able to now identify that equation, you can go ahead and use it. Substitute the parameters that you have, and then find the one that you do not have. Okay, so every single step we've discussed today is important. So if you cannot get everything immediately, you can always, try to go over it as many times as it will take you to understand, the steps for proving and, the steps for solving. So I hope, to an extent you're okay with what we've been able to look at. Okay, so as usual, I'll just give you some things to actually do. So I want you to try out these questions, number one and number two. So try solving, apply the steps, write out the parameters, see which equation you're supposed to use, and then try to solve. So if you solve this properly, you're supposed to get 90 meters and 2.5 seconds. So take your time. Take your time now to actually try it. Take your time to actually solve it. Don't just go without solving. Try to see if you can actually get it. Remember that for number two, there's a slight problem with the units. So don't forget what you're supposed to do there. Now, if you're able to successfully solve these questions and get the answers, please let me know in the comment section. Give me the feedback on how you are able to solve it. If you need further explanations, also tell me. I would also look into that and see how I can help you. If you have questions, you can ask them in the comment section, and I'll also reply your questions as quickly as possible. Now, also, I would like to try this out. If you want to, you can visit quizzes.com and you can play games on equations of motion. So you can just search and see if you can find one or two games on motion and see if you can play them to test if you really understood what we discussed today. But try to solve these questions. So it was lovely seeing you guys again, talking to you again actually, and communicating with you. Don't forget to like and comment and subscribe so that you can get weekly updates. Also, you can share it to your friends if you feel something that can be helpful to them. So I'll see you guys again next week. I hope you have a wonderful day. So don't forget to give me feedback on what you do not understand. Bye.